The vacuum will be released. Oh, it's super strength vacuum.
We won't tell the viewers that that's a weighted lid.
Oh, come on. So you might have a dishwasher at home, folks. We've got a parts washer here, haven't we? The keyhole surgery for the keyholes. We've got the roughness, we've got the height.
Yeah.
Hi, I'm Peter Haddock, and I'm here with something really important from the safety perspective. Been wanting to come and see the team here at Fireward and Reacton, and joined by Ed today to go round the factory. This is the joint HQ.
It is.
What have I got in my hand here? It's a little bit special, isn't it?
Yep, you have an automatic fire system.
An automatic fire system that is designed here and made here in the UK. And that design, while we're stood here now, all starts here, doesn't it?
It does.
In the simulation space. Tell us about why that's so important.
So design is obviously really critical because a lot of things we need to design have to conform to a lot of standards. Those standards dictate what the product should do, how it should do. So like all efficient design, modern design departments, Formula One teams through to aerospace, all the rest of it, it starts on a computer.
Right.
So we start on a computer because what we do on a computer is we take ideas, improvements, things we want to design, and we test those in a virtual space before we go and make something. So the heart of the products we make and the quality we make them to starts in this room.
So we've got simulation here, folks. So obviously this needs to spew out the contents, and the contents is two things, isn't it? Dry and wet for your systems.
Yep, we also have some other agents that are for different applications, clean agents, various other different bits for specialist applications. Majority of what's for Fireward, for example, is exactly that, dry and wet chemical.
So simulation those are there, folks. Now as we come round here, what's really important, come on Ed, is we've got some clever machines that we're going to see in a moment. And simulation also goes to simulation of the machines, the CNC that you've got through there. Again, why has this happened? Because I'm looking at something at the top here that looks very complicated.
Yep. So simulation, again, whilst we simulate how the product's going to work in the field, when we go to make it in the factory, you're going to see later, this gives the guys the ability to program the machines in a virtual way. So what you'll see on the right screen is loads of text that probably remind us of computers of old time.
Yeah, coding.
Coding. So the way the machines run is they work on executing a line of code. So what we use the simulation software to do is generate that code. And what that enables, in this particular instance, Ollie to do, is do some very, very clever machining techniques, geometry, so where we attack parts from, how we cut products. What that does is, in essence, gives us speed, so it makes us be able to make components quicker.
Yep.
We also, because of how we design the product, really, really like a compact product.
Yeah.
Problem with that is it has some really, really unique challenges, tiny challenges. We mostly machine to aerospace kind of tolerances.
Right.
So a very, very small window of tolerance in terms of it being correct or not correct. This enables Ollie to experiment with different tools, different machine settings, and as you'll see, they're quite complex machines. Ollie can sit here, have a cup of tea, and try 100 different ways of getting the machine to do what it needs to do without any risk of physical damage to the machines.
And also without, obviously, valuable elements here that are going through a machine and they're not right. Yeah.
Our wastage for what we make on the components, so our scrap, as you deem it, is almost nothing.
Wow.
And that is because what we see on the screen should be, and is in 99% plus, I'm sure I'll give you a different number, but it's very, very high, is what comes off that machine.
Yep.
So we're not, if you look at the code he's going through at the moment, there could be 60, 100,000 lines of code for a relatively simple part, but this will generate the code. But it enables that transition from the virtual world to the real world.
And that means we can make something like this. Right, it's time for us to go to another different spot. Come up this way. So Ed, we're now here with the machine. So we're talking about in the simulation. And you told me about this tiny little valve slot here. And that is critical. That's why I've had to take the cylinder apart. This machine does that. But why is that so important, this tiny little thing?
So different markets have different directives in terms of pressurized cylinders.
Right.
So we have to not only take into account the UK, Europe, abroad, etc., USA, Australia, all the continents that the systems will go to. So that particular challenge there with that little hole is, again, we've designed a very compact product, but we had to meet a technical specification. So we have to create a tiny little 1mm by 8mm slot that goes about 20mm, 25mm into the valve. And we needed a solution to do it, so we brought the machine behind, and it makes that tiny little slot, spinning a drill at 24,000 RPM, so very loud, very fast. They tend to run it at night because it's quite loud, but again, done at the unbelievable precision. So what it shows is the talent we have in the building to overcome technical problems, and a commitment from the business that despite the kind of technical issues we run into, we always invest to be able to do it here in the factory.
And I looked up for Nook before I came here, and that is really high end, isn't it? They are big leaders in the industry when it comes to this kind of machinery.
Machine control, automotive manufacturing lines, they're a phenomenal company, you know, arguably the best in the world at machine control.
So they've even got their own city in Japan, folks.
Yes,
so that's
they have,
great. So talking about the machines, we saw the actual components that we got the top here. We saw also that on the screen now. Let's go and see the machines that look out for it. Come on. So put my little valve back in my cylinder, so we're now compact. And inside here is where we're talking about all those fine tolerances in the design department where we started the journey. So tell me a little bit about the CNC machine. A lot of investment here, because not just got one, you've got another one as well here.
We've got three back to back here. It was a tight art getting them all in the same space. But so this was our first machine we bought in. This machine predominantly makes the bigger components, so the valve. This is our valve making machine. And the machines are graded by the size of bar. So this starts its life, you'll see down there is a section of bar. And the machine processes that bar on both sides to complete the component. So again, £500,000 investment in this machine to make these products. Again, the machines are only as good as the people that program and maintain them, and we've got some phenomenal people here that do that. So in essence, all the valves that you see across the range of products, this is the machine it's made on.
And because of the fine tolerances, folks, this is why you chose to make the investment here
100%.
And not outsource that, because that is absolutely critical, isn't it? Right, so come on, let's see a little small component. This one does. So we've been talking all about the valve all the time now, but this little thing here, it's quite complicated, folks. Lots of different elements to it. What is that, and why is that important?
So this will be recognised by quite a lot of your followers because it's a ferrule. So it's effectively used for a hose insert that is custom designed for a non-vehicle application. But for one of our other protection systems, we design a stainless steel hose. So again, we weren't happy with the quality that these components were being machined to. Again, very tight tolerances. So with a machine shop and the design suite, they go, well, I'm not going to buy them, I'm going to make them. So this is effectively what you'd see in a hydraulic hose. That's all it is. But it's a very small piece, and that goes onto a stainless steel hose crimped upstairs, and that makes a particular application, or particular product that we sell, and it has a stainless steel hose on it. So they're making your fittings for that.
From the large, relatively large, to the very, very small and tiny complex.
Well, we'll see some, as it goes, as we go upstairs, that's a very big component.
I think it's small.
No.
He thinks it's big.
There's a lot smaller components.
Come on, let's go see it. Right. So, folks, we've just been to see the actual CNC machines, but we're back here in the lab, Ed. Why are we in a lab? And it looks like we're doing some keyhole surgery, and obviously these are keyholes in the actual component, aren't they, Ed? Tell me what we've got here.
So this is our metrology lab. So this is where we're measuring. And there's a great saying, as I'm sure you're aware, what is not measured is not managed.
Correct.
So what we do here is we manage our measurements. So if we go to build, create, machine things, we need to be able to prove that we're making them to the standard that they should be. So this room is a climate controlled room where everything we make, things that we buy in, are brought up to a standard, measured, controlled, so that we can show a repeatable level of our quality that we do. Because our tolerances are so small, all of the equipment in here has to be highly calibrated by specialist people. So we have just that pinpoint obsession on quality all the time.
And that pinpoint goes into these key pinpoints on this particular product element here. Right, so let's go and have a look at some of the other elements here. So come on over here. I've spotted some more. So what have we got over here? Height gauge. So what's this all about?
So a height gauge is exactly what it says. It's for measuring height. But it's for measuring height at a level, again, high accuracy level. And there's a note as well that's put quite important in here. All of these systems talk to one core quality system. So we have, what John does is champions how we report on our quality. And the actual really interesting fact about this room is what it also tells the machine shop is how long the tool life is. Because we can see as the tool wears, the tolerance comes away, the dimension for the machine part comes away. So this is a great room for checking not only the dimensions that we create, but it's also a great diagnostics function. This room.
Of course.
So if we come up with issues, we find issues, you know, any kind of day-to-day running of a good quality department, you need diagnostics to understand, and this is your effective diagnostics and quality level.
And that's why you can get up to the standards that you need. Moving around here, so this, it looks a bit strange to me. It's like the component on a. Is it like when you go on a movie and you see that they're trying to get the key to then get into a door and it's squidged into something?
So this is quite funky. This is a surface measurement device. So this tells us surface roughness. So something smooth or rough. So we've got a little part here, and this is actually diamond finished on a machine.
Wow. Okay.
And it's, you know, better than glass smooth. But we need to know how smooth it is. And that little strange device with a bit of plasticine, but it's actually
it's more specialist.
It's more specialist. John won't appreciate that. The plasticine lookalike product holds the part in place whilst we measure the surface finish. And that particular device there is critical when you use O-rings. So we use a lot of O-rings to seal things. We have a lot of sealing faces. And in order for them to work, the roughness of those things, they have to be not too smooth and not too rough. So that's what we use that tool for.
Right, perfect. And finally, the plasticine goes down, but what have we got in here next to you here?
So this is one of the most classic kind of measurement tools. This is a shadow graph. So what a shadow graph does is predict a shadow. So just literally, if I put my hand in front of it, you'd see a shadow on the screen. And what we then use is this detector to pick up the edges of that shadow, and that gives you your measurement. So this is your kind of quality measurement 101. This is your go-to thing for setting up tools, measuring tools we use.
So, folks, we've had the keyhole surgery for the keyholes. We've got the roughness. We've got the height. We've got the other measurements in the shadows, folks, which shouldn't be there. And so it's time now to go and see, again, what elements go into making this a fire suppression cylinder. Come on, let's go. So you might have a dishwasher at home, folks. We've got a parts washer here, haven't we? And this is why we're looking at the parts washer, because this, very, very clean. I'm obviously holding it with a glove because it's not any other detergent you're putting in here, is it? No. What are we washing this with and why?
So as we talked about over there in that last clip about sort of how the machines run and the fire suppression, we cut in mineral oil. We do that for some serious advantages in terms of how we do it. Problem is, everything in the machine gets covered in oil. And we need to get it off the parts because our customers don't want oily parts. So we have a two-stage wash process here. So we effectively hot wash and degrease the mineral oil off. And then what we go ahead to do with the machine next to it is we use a rinse that basically creates the finish that you see on the products. So part of our side is quality should portray itself. So the surface finish you see on all of our products is not coated, it's not plated, it's the machine surface finish. So that gives our product that bright finish to know they're fully degreased and they're clean.
Always good to be clean, folks, but always good to wear the right protective equipment if you're handling anything with oils on as well. Come on, next on.
Let's go.
The problem is, folks, we've been talking about this cylinder and the components head, but there's nothing in this one. This is where that all starts, isn't it? Where we put in the actual product that's going to put out the fire.
It is. So this is our cylinder assembly line we stood in now. Behind us is the equipment that we use to fill our dry chemical systems. So we use dry chemical systems as our primary sort of agent in vehicle systems because it covers the broadest range of fire scenarios, coverage, you know, hidden areas in machines. and is the highest approved for that particular single agent. So that's what you'll find is where we use it. So behind us, we've got our original kind of powder filler machine down the end. Again, Genesis that we've had from day one. And actually, behind us now is the new equipment that's just arrived to automate the filling of the cylinders. So we now vacuum fill, which is far better for the environment you fill in. So there's no egress of dust. And we recover any of the wastage that would come. So we actually recover any excess powder that's around the necks of things, and we basically recycle the powder around the system. So it's a phenomenal bit of kit. And again, for us, investment in the right equipment for our staff to do the right thing is what it's about. And you know, it's another great investment and upgrade for the team.
And as the company grows, Ed, we need to fill more of these babies, don't we? So come on, but we don't just fill with the dry stuff. Come and have a look at some of the other things that are down here that we actually fill up as well. Come on. So we filled up the cylinder now, and but we need to test it. Like every step is the quality test. And you've got some happy gas mixed with some nitrogen here. So why is that a special mix that you've concocted to help us make sure this is right?
So part of our commitment to our customers is providing products of the highest standard. And one of the most important things with anything that holds pressure is being able to understand if it's leaking or not leaking. Key thing about not leaking, everything leaks. It's just the rate at which it leaks.
Oh, wow.
So what we need is we need a combination of gases to be able for a detector to pick up the leak rate. Everything leaks. So what we do is we have a mixture of helium and nitrogen that we'll see further down the process that the detector will use to determine the natural leak rate of the product being tested.
And so you said everything leaks. So you've designed it so it's okay to know that it leaks a little bit, or how does that work?
We precisely know on the detector you're about to see the years, months and days we would expect it to go from one pressure to another pressure based on the leak rate of that machine.
Come on, let's go and see this. It sounds a bit strange to me, but as we walk past here, we've got other bits and bobs. What have we got here?
So these are, as I said, this is where we fill our cylinders. So we've got different ranges of chemicals for different applications.
We talked about the dry, this is the wet.
This is our wet chemical. It's a combination, again, depending on the application, low temperature, various different other applications, offshore applications, alcohol-resistant foams. So various different applications require different
So as we come up here, folks, the one thing, I loving these machines here, but this is the one that matters up here, isn't it, folks? So look at this. This is the leak detector.
It is.
Right.
You've never said that before, have you?
No, I never thought I'd say that ever, to be brutally honest. But I've got to say, so now we're going to have to do a leak detection. So I'm going to set that up, folks, not with my cylinder, because it's empty, but with one that's full. So 2 hands now, Ed, because this is full, and it's relatively heavy in comparison to my little empty one. We're going to pop it on here, folks. We've got to get this barcode reader, because this is the important bit.
It is.
Traceability. This has its own QR code. I've bipped it in. That's now registered on the system. Now I've got to use my super strength to pull this down nicely. Seal it at the bottom there, folks, and press the button that matters. Are you ready? Oh, we heard a little bit of a choosh there. And now once it does, it's in test. So we're seeing the pass there, blue light. So what's going on right now?
So what the system's doing is we're drawing out to 0 atmosphere. So we're creating an almost space-like atmosphere where there's no air inside that cylinder chamber. When we've got the air low enough, we open a detector, and that detector can detect individual molecules of helium. That's how scientific you're going with the detector. So what it's doing now is it's bringing that down, and in a minute, it'll give the result. And the result is controlled at a leak rate of many decimal places that will tell you whether it has passed or not passed.
Okay, and what's really important about this phase is we talked about that leakage. Now, your products like this can be on a machine for 10 years, or they can actually be moved from one machine to the next if people actually want a new machine. So this leak rate is therefore really important. Oh, we've got a little
leak rate's good.
So we've got a flashing green light.
Yeah.
So it's a double thumbs up for us at the flashing green light test.
Yeah.
So we now know it's passed. So
That's correct.
Fantastic. Yeah. So can we lift it up now?
You can. The vacuum will be released.
The vacuum will be released. Oh, the super strength.
We won't tell the viewers that that's a weighted lid.
Oh, come on. So that's where it is.
Yeah.
Every single one gets tested.
Yeah.
That barcode links to that, which then links to the customer, which then links to the machine that goes on.
Yeah, we will only regulate up to the point of dispatch for the customers. Fireward then use that same serial number to then associate it to their machine. So we always give our customers, because obviously we have Fireward as a customer here and we have global customers.
Yeah.
Every serial number that leaves the factory is traceable right down to the very material you saw in the machine.
Fantastic, folks. So there we go. That's ready to go. So another happy customer ready for some fire suppression. Or is
you need to collect
Oh.
your label. So now, once you've passed it,
Yeah.
you need to go and get your quality label that will have been printed for you.
Okay, better go and get the quality label then, haven't we, folks?
Yeah.
Come on. So, Ed, the label has come out. Now I can place this on the machine. So here we have it. I've passed. My cylinder has passed. We're going to pop it on here. Right there for you, folks. I'll try and get it nice and neat like the rest of them. Oh, I think I've messed up there a little bit.
We're going to have to do that.
But that's not quality control, so we're going to get the team print another one and do it for themselves then.
Yeah. So basically that label there, you'll be accompanied with another label when it goes through the final serialization. That serialization followed it from the very start of this process where they were filling the cylinder all the way through leak detection. We kind of skipped a step a little bit where the serial number goes on it, but your quality label there reaffirms that traceability. And what that says is it's passed the leak rate, the date and time at which it passed. And then as a final step, when we package the products up here, we then do a stock check to make sure that serial number has followed all the way around here, all the way through this step, and the serial number that's on the outside of the box matches the product that's inside.
And so there we have it. Check it.
Check it.
Design it.
Design it.
Check it.
Check it.
Fill it.
Fill it.
Check it again.
Check it again.
Sort out the machines. Make sure they're measured correctly. Then we go around to all the different things. Then we test it. Then we get the labeling. Then we get the full traceability of all the different parts and the batches and everything else. And then, folks, the Fireward team in the UK take this product and whack it on a load of different machines, and then that process continues. Because what's interesting about the whole end cycle is this goes on. Yes, they've got then the team in the field will put this together. And what's really important about that is we need to go and find the one key component that actually makes this system super fast, and that's upstairs. So we're going to see the more components that help this do the job. Come on, Ed.
Let's go.
Now, Ed, we talk about quality, but also you're very, very keen on the Reacton brand, aren't you? And so this, unbelievably, is lasered with your logo on it, and it's even got a bit of colour on there.
It has. So I met a lovely company called Lotus Laser. They're from Basildon, just down the road. And when they said to me that I could have colour lasering, I was sold. So
brilliant. And the most important thing for me, you know, this might be fun to have the colour lasing and the brand, but again, there's traceability with the code of this particular individual part, isn't it?
So basically, as you can see, you've got multiple components that have been bolted together to make the valve. As you can see, they've got their own batch numbers, but when the valves return here to a built part back into stores that will then make their process down to where we've been in terms of filling cylinders, we then need to give that assembled valve its last stamp for our traceability. So these completed valves have come from manufacturing and assembly, and they're now being basically lasered with their final batch number.
And it's this one here, which I can't read because I need my glasses, but it's an 817, I think. So great to see that here. And we talked about stores there. We think we've got all these components, we're making them downstairs. You do actually have components that do come in, you buy in.
Of course.
And so, again, that is a quality control process, isn't it, for looking and testing those, and those go in and out of the lab as well, don't they?
Yep, so you've got in essence for us, 3 different types of components that we will sell to customers. We have non-traceable items,
Yep.
a screw,
Yep.
for example,
There you
is a good example of it. We have batched products, so products that we receive in as a batch, so chemical agents, cylinders, etc., come in batches because they're made as a batch.
Yep.
And then the final products, like the cylinders downstairs, are serialized products, so they're individual. So they're your kind of 3 categories of batching or traceability. So non-batched, non-serialized, batched products, and serialized products.
And that all goes into finding out all of the elements that go into one particular cylinder and enables the customer to come all the way back to ask you if you need that traceability in the future. So lots of stores up here, lots of things going on. Great to see the brand on the final product. And I'd say this is sort of completing our phase here for the actual Reacton piece.
It is.
Now it's time to talk to one of your colleagues at Fireward to find out actually how they put it on the machine and why it works. So thanks very much, Ed. It's been great to see you.
Lovely to see you, Peter. Thank you.